So the other movie I promised you was one about telescoping series, another small but interesting group of types of series. So the only two kinds of series we learn about in Math 31 where we can actually find the value that the series converges to is geometric series and these telescoping series. In general, in Chapter 9, we're just testing for convergence or the lack of it. We're not really trying to figure out what does it add up to. It just turns out that for geometric and telescoping, we can figure out what it adds up to. So we look at that a little bit so to build your confidence that if we say a series is converging, it is actually converging to something. So let's look at an example where the terms of the sequence are already in a form where we can see the telescoping happen. So this is an early exercise, number 56. And different people need to write out different number of terms to see what's happening. I like to write out a lot of terms. Just be patient and take your time. So the first term of this series is going to be when k equals 1. So I'm going to put k equals 1, and I'm going to say the first term is 1 over 3 minus 1 over 4. And I'm not going to simplify this because it's actually easier to see what's happening if you don't. So then I'm going to have k equals 2, and I'm going to say, oh, that is 1 over 4 minus 1 over 5. So you're probably already starting to see what's happening. So then for k equals 3, have 1 over 5 minus 1 over 6, and we keep going. So when k is 4, I'm going to have 1 over 6 minus 1 over 7, and so on. So you can see that if I start forming the partial sums, what's going to start happening. So the next thing is to start writing out the first two partial sums. So S1 is just A1, and so that's k is 1, and so that's 1/3 minus 1/4. So then when you do S2, it's going to be A1 plus A2, so it's going to be 1/3 minus 1/4 plus, then when k is 2, you're going to get 1/4 minus 1/5. So you can see that these guys are going to cancel, and you're going to get 1/3 minus 1/5. So then if you have S3, that's A1 plus A2 plus A3. So you have 1/3 minus 1/4, plus 1/4 minus 1/5, plus 1/5 minus 1/6. So you see the 1/4 cancel and the 1/5 cancel, and you get 1/3 minus 1/6. So can you see a pattern forming that if I add the first four terms together, all the inner parts are canceling. And so that's why it's called telescoping, because all the inside parts just kind of disappear and it collapses down to just the terms on the ends. So here you can see the 1/4 cancel, the 1/5 cancel, the 1/6 cancel, and you get 1/3 minus 1/7. So the idea then is to look for a pattern developing here for the partial sums sequence. Because remember that what we're trying to find out is the sequence of partial sums, because if I can find the limit as n goes to infinity of the sequence of the partial sums, that's going to be what the series adds up to. So now we're going to try and write a formula for our S sub n. And we're seeing every time we keep the 1/3, because there's nothing that cancels with the 1/3. And then all the inner terms are canceling, and the term that's left is 1 over, and then I look, when n is 2, I have a 5. When n is 3, I have a 6. When n is 4, I have a 7. So it looks like n plus 3. So the nth partial sum is 1/3 minus 1 over n plus 3, because all the interior terms canceled out. So we know that that limit as n goes to infinity of the sequence of partial sums is the value of the series. So let's look at the limit as n goes to infinity of S sub n, which is going to be the limit as n goes to infinity of 1/3 minus 1 over n plus 3, and it's pretty easy to see that this tail part goes to nothing, and I get 1/3. So that telescoping series adds up to 1/3. So there's some little twists to this, so let's talk about some of the other details. Usually the series isn't already arranged so nicely, and in that case partial fraction decomposition can come in handy, because let me go back up so you can see that this first one we started with was written as a difference. So see how it's already written as a difference. And then this next example that I'm looking at, there's a product in the denominator. So think back to partial fraction decomposition. We started with a product in the denominator and we rewrote it as a sum of terms. So that's going to be useful again here. I have these linear terms, so I'm going to say 1 over the 3k plus 1 times the 3k plus 4 is going to equal some a over 3k plus 1 plus some b over 3k plus 4. So a times 3k plus 4 plus b times 3k plus 1 has to equal 1. And if you're still having any trouble with partial fraction decomposition, please get some help, because it's really pretty basic algebra, but you have to think about what you're doing. So I'm going to pick k equals -1/3, which isn't simple, but at least that wipes out one of the terms. So then I get 3a equals 1, so a equals 1/3. And then I'm going to try k equals 0, just because that would be kind of easy, because that would give me 4a plus b equals 1. So 4a, which is 1/3, plus b equals 1. So that's going to give me b is -1/3. So my product in the given series is equal to the partial fraction decomposition that I've come up with of 1/3 over 3k plus 1 minus 1/3 over 3k plus 4. And then if you don't recall it, you can look back and remember that we talked about that if you have a constant multiplying a series, you can bring it out in the front because it's like factoring it out of every term. So you're going to have 1 over 3k plus 1 minus 1 over 3k plus 4. So this is more similar to the one that we started with. So again, you're going to write out the first few terms of the series and then start writing out the partial sums and look for a pattern in the partial sums. So S1 is just the first term, 1 over 3k plus 1, and I'm not going to worry about that 1/3. I'm going to bring it back at the end. S2 is going to be, well, this is when k is a 1, sorry. So that's going to be 1/4 minus 3/7. And again, don't simplify. We'll make it easier to find the patterns. So you have 1/4 minus 3/7 plus, now k is 2. So you get 1/7 minus 1/10. So that's your S2. This should be a 1, sorry. So then S3 is going to be 1/4 minus 1/7 plus 1/7 minus 1/10 plus, now k is 3, so 1/10 minus 1/13. And are you seeing that these interior terms are starting to cancel? So I have 1/4 minus 1/13. So let's see if we can find the pattern that S sub n looks like it's 1/4 minus 1 over, and then look at your terms to get an idea of what it's probably looking like, because when S is 2, all I'm left with is 1/4 minus 1 over 10. So it's looking to me, let's see, 2 corresponds to the 10. So I'm looking for some function of n where if I put 2 in it, I get 10. And that's a function of n that when I put 3 in it, I get 13. So it might take another term to get the idea of what's happening. So you're going to have 1/4 minus 1/7 for S4 plus 1/7 minus 1/10 plus 1/10 minus 1/13 plus 1/13 minus 1/16. And again, all the inner terms will cancel. So you get 1/4 minus 1/16. So our next leftover piece is when n is 4, I have 16. So I'm going to look at this pattern that says I'm going up by 3 each time. So that tells me I need a 3K. And after a while, you'll start seeing patterns like this. And when I do 3K, then I'm seeing that it's plus 4 each time to get the value. So this is going up in a linear sort of way. So I know it's a linear function. And I see the gap is 3 each time, so it's going up by 3 each time, so that's the slope. So that's my S sub n, or k, since I'm mixing indexes here, sorry. So S sub k as a function of k, or you could write it S sub n, doesn't matter. Same guy. So then we want to find the limit as n goes to infinity of S sub n, so that's the limit as n goes to infinity of 1/4 minus 1/3n plus 4. And clearly this part's going to 0, and so we get 1/4. So that infinite series is equal to 1/4. So there's a few other tricky examples that work in a similar way, but they don't look like it at first. So there's a couple of homework exercises you can check out. So one of them is this natural log. So notice that using properties of logarithms, you can rewrite this as ln of k plus 1 minus ln of k, so that you get that difference going on, so that you're going to have the cancels happen. So notice that it's one term minus another term, and that you start getting cancellations of the inner terms. So then number 67, I just want to point out that this one, you're going to have to factor to get started. So step 1 will be factor, step 2 will be partial fraction decomposition, and then continue on. So let me know if you still have questions after watching this video.